Good afternoon, everyone. I am Jacob Reiner, and I'm a junior in the Civil Engineering Department at UW-Madison. Today I will be giving a presentation on solutions for grid-scale energy storage. So imagine if we had 100% renewable energy. This would be great, wouldn't it? We wouldn't have to worry about climate change anymore, and a lot of our issues would be solved. When people think about this future, they typically only think about wind and solar technologies. However, energy storage technologies need to be equally invested in order for this to be a success without producing massive amounts of electricity that would be lost. In the figure below, the theoretical energy supply and energy demand curve is shown for a 100% renewable energy during the 2019 polar vortex. The gray part of the graph shows the energy storage that would be needed. As you can see, this is a massive amount. It's over a third of the power that would need to be supplied. At this point, we have less than 1% of what would be needed for this to be a possibility. This helps to show that we need to invest in energy storage in order for a wind and solar future to be a possibility. This graph was supplied by Wood Mackenzie, a research and consultant group in the power industry. Today I will be discussing the issues surrounding energy storage and the potential solutions that could solve the problem. So as I just mentioned, today I'm going to discuss the issues of energy storage and who it affects. The solutions, the two that I have chosen, are compressed air energy storage and battery storage, since they show the most promise for the future. And I'm going to do a cost-benefit analysis on each of those storage types. And finally, I'm going to provide a recommendation based on the information I provided. So what are the issues that energy storage addresses? The first is the big one, which is the rise in renewable energy. Renewable energy produces energy at a much more variable output than traditional fossil fuels. As you can see in the figure on the right, renewable energies are expected to make up half of the energy production in the world by 2050, which seems like a far time away, but when you really think about it, it's not that long. So what is the issue with a more variable power output? The issue comes when the energy supplied does not equal the energy demand. This is where energy storage comes in, and where energy can be stored and used at a later time. There is also an increasing energy demand, especially in developing countries. Energy storage can provide a more cost-effective solution rather than investing in traditional transmission infrastructure. There is also currently a non-reliable power grid in certain areas of the world, especially rural areas. If a power line goes out, those people could be without power for an extended period of time. However, energy storage can help to solve those issues with a backup power supply. Also currently an inefficient power grid in some places. Energy storage can help to solve these issues by creating a more efficient power grid by essentially flattening the energy supplied and energy demanded curve. This will be especially important with the rise in renewable energy. The solution to the issues I just went over is pretty straightforward. It is grid-scale energy storage. According to the U.S. Department of Energy, it has advantages such as increased sustainability in the power industry, lower cost in the long run for consumers and producers, a smaller footprint both environmentally and physically, and it will also lead to increased renewable energy at a faster rate. What is not so simple of how it will be implemented and what form of grid-scale energy is the best. There are several forms of grid-scale energy storage, ranging from batteries all the way to mechanical flywheels. Many of these forms are not very economical and not very efficient. However, there are a few forms of energy storage that look promising for the future. The two that I'm going to go over next are going to be compressed air energy storage and lithium-ion battery storage. The first system I'm going to discuss is compressed air energy storage, also known as CAES. How this system works is it converts electrical power, primarily produced by renewable resources, into compressed air. It does this by compressing the air into an underground cavern, as can be seen in the figure to the right. There's also a heat storage tank to capture any energy that might be lost due to heat to increase the efficiency of the system. This energy is then stored for later use when energy demand is high. It is then released, which causes expansion in the system and can spin a turbine, which then causes the power to be returned back to the grid to the consumers. One of the main advantages of this system is it has a very large capacity. According to the Pacific Northwest Research Institute, it has the potential for up to 400 megawatt hours. This is enough to power over 13,000 homes for an entire day. It also has a long lifespan. While many battery alternatives for energy storage only last from 2 to 10 years, this system lasts up to 50 years. In addition to the large capacity and long lifespan, is a low cost per unit storage. This is very important because it makes it an economical choice for producers to choose. One of the disadvantages of this system is that it is very complex. This makes maintenance very difficult and possibly very expensive. Additionally, it is very difficult to find leaks within the system, so energy could be getting lost and it could be very difficult to find where it's coming from. This leads me to my next point, that it is also inefficient. Without the heat storage tank, this system only retains about 50% of the energy that is put into it. With the heat storage tank, it is slightly better, at about 70 to 75% efficiency. While this is higher, it is still not very good compared to batteries that have about 95% efficiency. This system is currently also limited geographically. While you can use above-ground compressed air storage, this is much less economical than natural caverns, which is really the only effective, cost-effective solution at this point. The next solution I'm going to discuss is lithium-ion batteries. These batteries store generated electricity as electrochemical energy, and then that storage energy is released to the grid at a later time when energy demand is high. These batteries work the same way they do in your phones and laptops, just at a much larger scale. Some advantages of using lithium-ion batteries is they have a very high efficiency. Only about 5% of the energy put into them is lost. There's also no geographical constraints. While the batteries do have to be housed in certain conditions, they can be put pretty much anywhere on Earth. According to the Environmental and Energy Institute, these batteries take up about 100 times less space per unit energy compared to the compressed air energy storage. They also have a very fast discharge time, in the matter of seconds, compared to compressed air energy storage, which is a matter of minutes to hours. Some disadvantages of these batteries is they still have a higher cost than compressed air energy storage. They also only have a medium lifespan of about 10 years. This is much lower than the compressed air energy storage, but it is also relatively high compared to the other batteries. So now that I've discussed both technologies, I'm going to do a cost-benefit analysis to see which technology is better. Both technologies have their advantages and disadvantages, but at the end of the day, they do the exact same thing. So what it really comes down to is which one is more cost-effective. The figures below were produced by the U.S. Department of Energy, compiling lots of data from lots of different companies to find averages of how much these energy storage systems cost. As you can see, there are many costs involved in energy storage, but the one that matters most is the total project cost in dollars per kilowatt hours. This is the amount you pay for the electricity coming out of the energy storage. For compressed air energy storage, this number is $105 per kilowatt hour. For the lithium-ion battery, this is approximately $470 today, and projected to go down to $360 in 2025. Based on the cost-benefit analysis, I'd recommend compressed air energy storage should be used when geologically possible. When it's not possible, I'd recommend lithium-ion batteries since they are a close second. Lithium-ion batteries are also something to watch within the coming years. Research done by Energy and Environmental Incorporated showed that by 2025, lithium-ion batteries should be profitable for large-scale energy storage. In conclusion, today I discussed how energy storage is critical for renewable energy. I also discussed two potential solutions for energy storage, and did a cost-benefit analysis on those two solutions. If you're interested in renewable energy, I encourage you to check out some of the research that has been done on energy storage and some of the innovations that have taken place in the field. Please let me know if you have any questions. Thank you.